Although it doesn't say explicitly that this is geometric growth, by the formula, since it's an exponential formula, we can kind of guess that this is going to be a geometric growth problem. So we want to find Tn and T7. And what we could do is to get the common ratio, what we can do is find S, the value of S, for any consecutive terms, and then we can subtract to get the t term. So for example, if I want to get T7, I can do S7 minus S6, and that will give me T7. Okay, because S6 plus T7 gives me S7. So I'm going to work out the T7 value here. So plugging in n equals 7, I'm going to get 2 to the power 7. That looks like it's going to be 128. So 4 times 128 minus 1. Okay, and then minus 4 times, and then we're going to do S6, so 2 to the power 6. Minus 1. So this works out to be 4 times 127 minus 2 to the power 6 is 64, minus 1 is 63. Factor the 4 out, and that's equal to T7. So T7 in this case works out to be 64 times 4. So 4 times 64, and that becomes 256. So T7 equals 256. Now we can do the same thing for any other term, and if we have two terms of a series and we know it's geometric, we can work out the common ratio. So I'm going to do for T6. So S6 minus S5 is equal to T6. So plugging this in, I get 4 to the power 6 minus 1 minus S5 is going to be 2 to the power 5 minus 1. That's going to give me T6. So this becomes 4 times 2 to the power 6 is 63. 2 to the power 5 is going to be 32 minus 1, so 31. Subtracting these, we get 4 times 32. Okay, this works out to be, what's that going to be? 128. So T6 is equal to 128. Okay, so if T7 is equal to 256, T6 is equal to 128, we can say that the R value is going to be determined by dividing consecutive t values. So R is equal to 2. So we solve for T7. We want to find Tn. We need to find the first term, and we need to determine the R value. So to find the first term A, we can use this concept that S1 is equal to T1, which is equal to A. So plugging in 1 into that equation, the S equation, we get 2 to the power 1 minus 1, so A is equal to 4. The general formula for Tn then, Tn is equal to A, R is going to be 2 to the power n minus 1. So there it is. There is our Tn formula and our T7 value. So what two things allow us to describe geometric growth? The two things that we need is a starting point, similar to arithmetic, and the common ratio or common multiplier. We'll call that R. So how do these elements relate to exponential growth? Well, the exponential growth formula looks like this. The n value is equal to the start value. Our growth factor is our multiplier. and to the number of cycles. So this is number of growth cycles, or how often I apply the growth factor. So how do these elements relate to exponential growth? The start value is equal to A, and the growth factor, or our multiplier, is equal to the common ratio R. And then finally, how can we calculate the common difference in the common ratio of a sequence? The formulas are very similar, except the common difference is calculated using the slope formula, or using differences. So if I have two terms, TB to TA, if I subtract those, I'm going to end up with the change in the Tn values. And if I divide that by the change in n values, I get the average change per step, or the common difference. Okay, so this represents the essentially slope, but it works with the changes. The common ratio is very similar. So one easy way to remember this is common difference is found by differences or subtraction. Common ratio is found by division. We want a ratio. So the ratio of B to A represents the number of times we use the common ratio, which is going to be B minus A, so to the exponent. Now we could write this as, just solve for R and just say that it's a root of B minus A represents the root that we're going to use, and it's the TB divided by TA gives us the common ratio. So, but really this just represents the number of times, this B minus A, same as here, it represents the change in n, or represents the number of steps that it takes to get to from TA to TB. So these formulas are very similar in that, but the difference is common difference uses differences and we divide. Common ratio uses a ratio and we root.